Hey there, friends of mathematics. Today we're talking about Math 105, section 2.1, and we're going to be dealing with inputs and outputs. And as you know, when we talk about a function, we have some things that are going to go into our function, and those are our inputs. And our function f will deliver us some outputs. A function being a rule where we have some input that leads to some output. When we talk about this, we're going to look at things in 4 different ways. We're going to look through formulas. We're going to look through tables. We're going to play verbally, and we're going to play with graphs as well. And let's start out with just some formula. Suppose f of x is equal to, I don't know, x squared over 2x plus 1 plus, let's say, 1 over x. Now, this x value here is our input. And we can see that it occurred at 3 different places on our formula. If I was to say f of 3, the input would be 3, and then the output would be all of this trash over here. And I would have to say that we would have 3 squared, 2 times 3 plus 1 plus 1/3. I don't really care about simplifying it. I'm just talking about that the input is 3 and the output is this piece right here. I don't necessarily have to input something like x. I could input something like a, f of a. Now my input is a, and the output is going to be a squared over 2 times a plus 1 plus 1 over a. I can even get crazier than this. I could do something like f of a plus 7. And what we're doing is my input value is a plus 7. And everywhere that I have an x on my formula, I'm going to be using a plus 7 instead. So we'll have a plus 7, and it's important to have parentheses, quantity squared, over 2 times the quantity of a plus 7 plus 1 plus 1 divided by a plus 7. And here I didn't need to have the parentheses. I could put them, but it doesn't really matter one way or another. So now we can look at these functions that are expressed as tables. And we can start very small. If I said, hey, what on God's green earth is f of 0? We can say, all right, when I have an input of 0, the output is -1. We could say g of 0. I'm inputting a 0 for x, and I'm using my x column there. And then the output, this cell right here, is what g of 0 is. And sure, we get 1. I could ask you to do different things as well, and we'll frequently be asked to do different things on our exams. If I was going to say f of what thing equals 5, and you would say, okay, I'm looking for the particular input when the output is 5, and we can see that the output of 5 occurred right there, and so x would be equal to 2. But I think what's probably the most common problem is going to be they're going to ask you for an output where it's also listed as an input. So something like this, g of what is equal to 0. And I think that there are many students that don't know if we're looking at the 0 in that x column or the 0 in the g. And we're looking where the output is 0. And so we're looking at that one right there. And the answer is when x is equal to 1. In this next problem, We're looking at a function given to us as a graph. And in part A, we need to determine the coordinates of the points P and Q. So point P, when the input is B, I can say f of B, we get A. The input is B, the output is A, and so point P can be described as B, comma, A. The input, comma, the output. Similarly, Q, we can write that as D, comma, E. Now, I know that some of you want to say, oh, D and E, these are below or to the left of the origin, and so they should be negative. And yes, they are negative, but if I just gave you, say, D, that would be a negative value because it is to the left, okay? So in part B, we're asked to evaluate f of B. And so my input is B, and the corresponding output is A. Let's keep going, friends. In question C, we want to know what on God's green earth is X when the output is E. And so we can see that when the output is E, I needed to use a D to get me there. And so X equals D is our answer. I think this next question, part D, is the craziest of the bunch. And we suppose that C is equal to f of Z. And Z is equal to f of X. What is X? And so what I think we're going to do is we're going to start just working this thing backwards. Suppose C is equal to f of Z. Well, we can look on our picture and we can see that C is a Y value or an output, and the input there is what? What does Z have to be here? Well, I need some input to give me an output. It looks like Z is equal to 0. Yeah. Let's keep going. The next question then says, well, if 0 equals f of X, what is X equal to? And now we need to look where the output of f is equal to 0. I'll give you a second. Looks like it happened right here. Yeah. So when the output was 0, the input, oh, you got it already, is H. Our final question asks us to think about if f of B is equal to negative f of D. If f of B, mind you, f of B is right here. There's B. F of B is that value. And suppose that's equal to negative f of D. Well, f of D is equal to E. That's a negative value. So what could we know? I don't think we know anything about D and B. We don't really know how far these values are from the x-axis, but I think we can conclude that, yeah, just that these two are equally distant from that. We could say that A is equal to negative E, or the other way around, that E would be equal to negative A. All right, friends, we have one last flavor of function to talk about before we're done. All right, friends of mathematics, our final take on input and output is going to be this verbal description of a function. Let S of t be the number of pieces of Michigan swag you own t days after being accepted to the university. T is our input, and the units of the input are days. And the number of pieces of swag that you own is our output. So if I was going to say something like this, S of 3 is equal to 10, the input is 3 days, the output is 10 pieces of swag. And we can interpret this 3 days after acceptance to U of M, we own 10 items of swag. I guess Michigan swag. Now, I want us to take a journey with me. And if I say S of 7, we certainly know that the 7 is the number of days, yes? Sure. But even though I'm not given this thing equaling something, the output is still S of 7. 7 days after acceptance to U of M, we own S of 7 items of Michigan swag. Yeah. And so even though I don't have a specific output value like I had before, S of 7 is in and of itself an output. Let's try one more. Let's try one more. If I said something like this, S of, oh, I don't know, is equal to 10. Yeah. Or no, what's not 10? Let's say 15. Yeah. In this case, we're looking for on what day after admission have we collected 15 items of swag. So we've played with inputs and outputs, and we're going to further this in section 2.2, talking about the collection of all inputs and the collection of all outputs, called the domain and the range. Until then.